In this screencast, we will again be solving linear equations, but this time we are going to solve linear equations that potentially have multiple fractions in them. The strategy that we're going to use is we're going to solve the equations with fractions by multiplying both sides of the equation by a common multiple, specifically the least common multiple is easiest, of the denominators. So this is going to be our strategy. But in order to do this, we got to multiply both sides by some number. This will require us to do multiplication with fractions. So first, let's recall the way we multiply fractions is if you got a fraction a over b times a fraction c over d, you simply multiply straight across. You've got ac over bd. So let's take a look at some examples down here, see if we can simplify these fractions. And we're going to use this knowledge right here as well as some other knowledge from the past as well. So when you look at this one, you may be thinking right away, okay, this is the same thing as 1 times 2 times 3 times 4 times 5 over 2 times 3 times 4 times 5 times 6. Because you would multiply straight across the top and multiply straight across the bottom, which is exactly what this is saying. And yes, this is true. If you did 1 times 2 times 3 times 4 times 5, you've got 120. And then 2 times 3 times 4 times 5 times 6 is 720. And then, of course, you would have to reduce that. You'd have to think, what common factors do both 120 and 720 have that you can divide out? Well, actually, 120 is a factor of 720 itself. So 120 goes into 120 once, and 120 goes into 720 6 times. So this expression right here simplifies to this fraction 1/6. However, what we just did was a complete waste of time. It's actually not how I want to do this, and it's not the way I want to do these either. Recall that we can divide out common factors in a fraction. That's essentially what we just did here. But I want to do it much, much sooner than right there. In general, if you've got a times b over a times c, as long as a is not 0, you can divide out those factors, giving you b over c. So that's what we want to do from the beginning. We want to divide out the common factors right from the beginning. From this expression right here, not all the way over here. We did a bunch of computation to get over here. So right away, we want to divide out common factors. So there's a common factor of 2. 2 divided by 2, of course, is 1. 3 divided by 3 is 1. 4 divided by 4 is 1. And 5 divided by 5 is 1. And notice what we're left with, 1/6. We can very quickly get to that 1/6 by dividing out common factors first. Notice when you don't divide out common factors first, you end up creating larger numbers that you don't need to deal with, right? You have to think about what can I divide out here, and I had to get that 120 and 720 in the first place by doing these multiplications. So you want to reduce before actually doing the multiplication, and that's how we're going to approach this problem and this problem. With this problem, notice that we don't have two fractions. However, we can quickly make 12 into a fraction, and you don't necessarily need to write this if you know what's going on. But 12 is equivalent to 12 over 1. So instead of going and doing 12 times 3 is 36 over 1 times 4 is 4, not that 36 is a big number, I'd rather reduce first. So divide out common factors. Well, what is 12 divided by 4? 12 divided by 4 is 3. You're left with just 1 in the bottom, and we still have 3 times 3 in the top, which is 9. Again, you would have gotten the same thing if you did 12 times 3 is 36, 1 times 4 is 4, and then 36 divided by 4 is 9. However, we're not creating the larger number of 36 when we divide out the common factors first. So this is very quick and easy. So over here, we're going to do this one again, but I don't want to even have to write that as a fraction. Realize when you're multiplying a fraction by a number, that number would multiply into the numerator, not into the denominator, and definitely not into both. That number would only multiply into the numerator because that number could be written over 1. But instead of doing 15 times 2x, we're going to do the division first. So 15 thirds is 5. So we're left with 5 times 2x. 5 times 2x is simply 10x. Now that we've looked at how to efficiently multiply fractions, meaning divide out common factors first, we can now actually get to solving linear equations that have fractions in them. And again, this is going to be our strategy. To solve linear equations with fractions in them, we're going to multiply both sides of the equation by a common multiple of the denominators. And the reason we're choosing a common multiple of the denominators is so that when you do the multiplications, you no longer have fractions. Let's take a look. Again, we're going to solve equations with fractions by multiplying both sides of the equation by a least common multiple of the denominators. Again, least is in parentheses here because you can do it without the least common multiple of the denominators. However, it's easiest. The simplification part is simpler if you use the least common multiple. So we want to solve each equation for its variable. We're going to take a look at this one right here. So you can see, obviously, we have an equation with a bunch of fractions in it. You could pursue this in the way that we pursued problems previously. However, that's going to require you to do a lot of adding, subtracting, and dividing fractions, which a lot of people don't like to do. So we are going to instead multiply through by a common multiple of the denominators, and you see that's going to wipe out the fractions completely, making it an easier equation for us to deal with. Let's attempt this one. As you can see, we've got three different fractions in here with denominators 2, 4, and 3. We need a common multiple of those three numbers. A multiple is a number that each of those goes into. For example, 8 is a multiple of 2 because 2 goes into it evenly. 8 is a multiple of 4 because 4 goes into it evenly. But 8 is not a multiple of 3 since 3 does not go evenly into 8. So we need a number that 2, 4, and 3 all go into. And the least common multiple of those three is the number 12. So as with all other linear equations, we need to multiply both sides of the equation to maintain the balance. So we're going to multiply both sides by 12. Notice we're not just multiplying the individual fractions by 12. For example, this 1 is also going to get multiplied by 12. We got to make the whole entire sides 12 times bigger. And of course, hopefully you can see this requires use of the distributive property. So the 12 distributes into each of those two fractions, and the 12 is going to distribute into the fraction x over 3 and into this 1. Let's just first write this distributing out without actually yet doing the computations. So the 12 is going to multiply in with the 3x over 2. Then, of course, we have minus here. So we've got minus the 12 is going to multiply into the 3/4. And then we have this equals, this 12 is going to multiply into each of these. So we've got 12 times the x thirds minus 12 times the 1. So we haven't actually done the computations, just writing out the distributing of the 12 to each of those pieces. Now let's actually go through and do the computations. And as we saw on the previous screen, let's do the simplifications first. So instead of doing 12 times 3x, let's do 12 divided by 2 first. 12 divided by 2 is 6, and then you're left with 6 times 3x is 18x. Over here, let's first do the 12 divided by 4, which is 3, and then you're left with 3 times 3 is 9. So minus 9 here. Equals 12 divided by 3 is 4, so you have 4 times x left is 4x, minus 12 times 1, there's no division there, it's just 12. And now we have an equation here that is equivalent to the original equation, but this new equation doesn't have any fractions in it. And now we would solve this like we did in previous screencasts. So first we need to get x on one side. Perhaps we'll subtract 4x from both sides. You could also subtract 18x from both sides if you'd like. On the left-hand side here, we're left with 14x minus 9. And on the right-hand side, we're left with negative 12. Now to undo what's happening to x, we would add 9 to both sides first, giving us 14x equals negative 3. And then if you divide both sides by 14, you get your solution, which is x equals negative 3/14. Again, don't convert this to decimals. And if the numerator was larger than the denominator, also do not convert it to mixed numbers. Negative 3/14 is a legitimate number itself. We solved our first equation with fractions, and the key here is to multiply through by a common multiple of the denominators to wipe out the fractions entirely. So we can do that here. If you look at this equation, we've got denominators of 3 and 5. So first, what's a common multiple of 3 and 5? Well, just 15, and that's the least common multiple. So we'll multiply both sides by 15. We've got 15 times this and 15 times this. And just like before, we don't want to multiply the 15 into the numerator at this point. We want to first do the simplification. So we've got 15 divided by 3 is 5. And then it's 5 times that whole sum up there. So I'm going to put parentheses around that. I need to realize that I need to distribute the 5 in there. 5 divided by 5 over here is 3. So this numerator is going to be multiplied by 3. So let me just rewrite that, and then we'll do the distributing. We've got 5 times the quantity x plus 5 equals 3 times the quantity 2x minus 1. And now, this is an equation without any fractions. We can simply distribute on both sides and go from there. So if you distribute the 5 in on the left, you've got 5x plus 25 equals, distributing the 3 on the right, we get 6x minus 3. And now this equation looks very similar in style to this one. So if we subtract 5x from both sides, that would give us 25 equals x minus 3. Add 3 to both sides, giving us 28 equals x. This is our solution. Now, I want to point something out. You could have thought about this equation here in a different way than how we thought about this. For both of them, we multiplied through by a common multiple of the denominators. But with this one right here, let me just rewrite this so you can see it clearly. You had x plus 5, that sum over 3, equals the difference of 2x and 1 over 5. If you have an equation like this, you can use this basic principle here. When you solve proportions, if you have a over b equals c over d, then you can, what a lot of people call cross multiplying, you get a times d on one side and b times c on the other side. That's always true. So this requires that you understand what a proportion is. A proportion is the equality of two fractions. So in this case, we had this fraction equals this fraction. That's the reason this is a proportion. However, this over here is not a proportion. You don't have one fraction on one side and one fraction on the other side. So cross-multiplying sort of thing would not apply here, whereas it does here. So if we approach solving this proportion by cross-multiplying, the 3 here would multiply with the 2x minus 1 and be on one side, which is what we have right here. And then the 5 would multiply with the x plus 5, which would make up the other side of the equation. And then you would go from here and solve just like we did. So it's another option you can use if you're solving an equation with fractions that happens to form a proportion, which is when one fraction is equal to another one fraction. We will get some practice with distinguishing between proportional and non-proportional linear equations with fractions in the coming screencast.